All right, amazing. Thanks, Espen, for the setting up the stage. Um,
I think
how do I move to the next?
there
Okay,
you go.
great. Okay. Yeah. So this is a brief talk, mainly because me and my colleagues, the few collaborators listed here, work on auctions in financial markets mostly, and then we have noticed that there is a striking parallel between what happens in financial auctions and multi-agent security, and specifically cooperative AI. That a few insights that may interest um, this audience, taking sort of say like the lessons that I learned from running those markets for multi-agents to interact with each other, and then how kind of brainstorm how can we bring them back to the research slash theoretical setting. Right. So like overall in this talk, we will say that using learnings from running high frequency auctions for algorithmic agents with real economic incentives and hyper adversarial behaviors, how can we improve our research framework in multi-agents systems and their security? Okay, so like, the very first point that I want to make, that I see a discrepancy, is that often in multi-agent security research, we assume commitments explicitly or implicitly, right? So like we can see examples of this in, for example, simulation-based cooperation, right? We say like, oh, the US and AI can sort of get access to the other person's source code or simulate the other AI's actions before determining your action. So that in that situation, you're implicitly assuming that the other AI or person is committed to actually executing the code that they are saying to run. So that's like implicitly assuming a commitment. This is even more evident in things like open source game theory, program equilibrium, right? In which case, well, you are explicitly assuming the other AI credibly exposes your source code that you can simulate or see or compute gradient on. And of course, we see this more in approaches that involve economics, markets, mediators, contracts, right? So in the more traditional multi-agent reinforcement learning literature, we see things like parameter sharing or training process. We see parameter sharing, or like a centralized training process, or like execution time integrity, that all assume commitments in one way or another, right? For example, in the training process case, decentralized execution with centralized training, you assume that the agent you are coordinating with is actually trained in that process. Okay, and of course, it's not new to borrow from real-life experience of dealing with those multi-agent systems when we are talking about our research. We've seen things like ad auctions or selling of concert tickets, or in this case, what we deal with mostly high-frequency trading and inclusive pricing. Okay, so one of the first example is stackable games and commitment tax, which we are, I guess, familiar with in the multi-agent game theory literature. Right, we often assume that all those agents are playing a stackable game, and sometimes they can manipulate the incentives of the game by deploying a commitment, or like or deploying a contract that promises, say, some kind of like split agreement with other agents, and therefore create this collusion device that people can use. And theoretically, if we do some analysis and we throw our, say, cooperative game theory onto it, right, like for the Shapley value, then we can get some kind of like theoretical prediction of how the game would play out. But however, all of those methods or like theory basically boils down to whoever commits the first wins, right? However, which is a deeply unsatisfying result, because like it just results in everybody trying to commit first, and um, and that situation is kind of uninteresting. But then what we see in practice is, of course, the theoretical result predicting that the first person that commit wins relies on the fact that you're implicitly assuming common knowledge, right? You're assuming that common knowledge can be implemented at a what's that? A snap of a finger. Right, can be implemented very fast. But however, in practice, we know that common knowledge is subject to speed limits. Of course, I draw a light cone here. Common is of course subject to the speed of the light, but of course it also, more realistically, is subject to the propagation of information, the speed of propagation of information in social networks, right? So namely, how do I make a commitment normally? It's like, oh, I make a website, I deploy a mechanism on a website. I make a website, and I say, for example, I tweet the website. I send an email of the website to different people in the market. I do some PR. I go on TV and talk about the website, right? So like you implement common knowledge in that way. But those kind of things take way longer than theoretically in game theory settings. We assume like after I deploy the mechanism, just everybody knows about the mechanism, right? So then in this case we do see some discrepancies, and therefore and this translates very well into the AI literature, as agents are inherently have bounded rationality, right? And they're not logically omniscient. So we don't run into the meme here, right? Where agents do commitment attacks on each other. Okay, so another example is strategic mediators and costly contracts, right? So those two things we typically don't see in traditional multi-agent literature or traditional game theory literature, right? So the idea behind this is to say that we want mediators or contracts or markets because they provide a credible way for agents to interact with each other, right? However, credibility comes at a cost, right? Why should I be the mediator? Is of course you pay me something, and that's and then I have a long-term incentive to be credible, and therefore I charge you some money, I become the mediator, right? Evidently by say Google or Apple, right? Say Apple, I think they charge 30% of the App Store, right? Because they act as a mediator between two sides of the market. Right, namely the app developer and the users. So credibility comes at a high cost, and most of those platforms or mediators are profit-seeking. So then, relating to the previous point, is that I see there's a understudy of how agents can manipulate game interactions in multi-agent settings via the use of strategic mediators, right? So for example, they can bribe the mediators, they can even create a collusion device that bribes other agents to bribe the mediators, things like that. Okay, and of course, here's the mandatory large language model slide, since nowadays, we talk about multi-agent security, but most of the work or realistic systems that will be deployed are on large language model side. So then, like, how concretely can our studies from multi-agent security matter in the large language model side? Is that one example, right? One very simple example is to say that, oh, here we see OpenAI GPTs store, right? There are a bunch of AI applications made via GPTs, and the user usually have a high-level prompt describing some idea, and that they want to be satisfied. And then your job is to a good application store should route this high-level prompt to the GPT that they think would best satisfy the user's high-level prompt. Right, so we already see this via many, mixture of experts or centralized routing systems. But then the idea is to say, if we were to believe that AI apps market develops similar to the early internet market, right? Then we would expect this sort of routing market structure to change, right? Because in early internet, people also made applications, and those applications are just early internet website that make money from user order flow was a good word. A user's activity on their website. Yes. So then early internet search engines were also not very effective in routing or distinguishing which website can best serve the user's interest, right? So then what people developed is that they do search engine optimization by, for example, they put a lot of hot keywords on their websites in order to get routed more, and therefore they would make more money, right? We still see that today. For example, if you go on Amazon and you search for some commodity, then sometimes another totally irrelevant commodity would come up simply because, you know, the vendor of that commodity put on some keywords that makes them, you know, get suggested by the recommendation system. So, you know, we kind of, you know, if the market of AI apps develops similar to internet, then we would see such actions to try to do, say, search engine optimization on the AIM routing side, right? And so in the internet case, how do we resolve this? Well, we kind of resolve this by, because this is fundamentally an elicitation problem, right? Because previously, how we elicited the user's preference is by, you know, using a recommendation system. We ask the user what you want, as in like we do like supervised learning on the past data. But then another way of, but in that case, you're kind of assuming the user's preference is static, namely like the order that you recommend the vendors or websites to the users does not change the user's preference. However, in practice, we know the order definitely matters, right? Like or else Google wouldn't put like the ads at the top of the banner. So then, you know, in a world where we assume the user's preference is dynamic, which they are, then we use a combination of recommendation systems, which are essentially centralized routing systems, and sort of say this auction approach, or like, you know, what I would describe like a decentralized market approach, in which the vendors or the applications or the websites bid. You know, they first do self-evaluation. How well can I satisfy this user's prompt or this user's search query? And then they would bid on participating in an auction, and their auction bids would be boosted by a score calculated by the recommendation system, and then, you know, the total result is then calculated for the routing. So then, you know, concretely, this situation of like a user have a high-level prompt and a bunch of AI apps wanting to make money off of this user. This is a classic, you know, multi-agent interaction that we can foresee that is for sure going to have huge economic value. And if this system is not made secure, then what would happen is similar to the early internet SEOs, right? A user goes on to the, say, GPTs store, or, you know, search something, and then a bunch of trash applications are going to come out, and it's not good. So then, you know, it is important, I think, to see or to validate the thesis that whether this will become true, and evaluate the you know, whether this combination of ad auctions or recommendation systems make sense in the GPT case, right? Like, for example, can they do self-evaluation of their expertise effectively? Can they participate in those auctions effectively? And then, you know, maybe as a first step, can you even do SEOs on those routing systems? But of course, you know, concretely to the takeaways, there are several questions. Those 4 questions, if you only remember those 4 things, I think it's good to have some kind of self-doubt, right? It's what drives people forward. So then, you know, when we implement and deploy AI agents in the real world to engage in few-shot coordination tasks, what new behaviors should we expect to emerge? And are the assumptions that we make in MARL, in Marrow, and cooperative AI realistic? And what would be the security properties of those commitment devices be? And what will those security properties of the commitment devices in mind will the AI still coordinate robustly? Food for thought. That should be all.
Any questions, both online and offline? I think otherwise, first off, I'm curious how you think of like the difference between the incentives for the mediator and building this like decentralized market mechanism. So, for example, the Apple App Store does have ads and so on, and there is trash on there, but you still they have a very high incentive due to their brand value or something like this to have high quality apps at the top. What do you think will change if we do it in a decentralized manner?
I mean, first of all, you open up to a lot of attack interfaces, which I think is inevitable, right? Because we do have ways to, sort of deploy those attacks on top using decentralized methods, whether you like it or not. So I think as a first step, it's important to study the attacks, and then we study how do we, how do we, how to say, correct the incentives back onto the right track. Yeah. Of course, I think realistically, if today somebody were to make a centralized routing system, then I expect the first thing that would happen is that somebody sells those gadgets that you can how to say, append to your AI application, such that makes it more likely to be routed, and then you can charge, basically get more user flow, and then because your pricing is based on how many tokens processed, then you make more money, right?
Yeah.
And then like after everybody started using those gadgets, then it makes no sense to use, right? then everybody should get the exact same routing as they would have before, and then somebody would be coming out with a new market structure. Yeah, it's like the Clear thing, right? Like if you ever go to an airport, you see like Clear is this service you can purchase to skip forward in the security line, and if everybody used Clear, then it's like you have the exact same latency to security line as before. Yeah.
Yeah. So just like search engine optimization is an attack, just like
yeah.
Figuring out what happens with these routings.
Yeah. I mean, attack is a word I like to use because I don't have a negative connotation to this word, but I understand many people may have.
Yeah.
But yeah.
Nice.
It's just more market operations. Yeah.
Yeah. No, attack is, I think, is a good way. You exploit the system as it's designed.
Yeah.
Do you think it's loud enough for people?
I think so. Can everyone hear us online as well? Just react or write in the chat or something. All right, I will assume that it's loud enough. Okay, fair. Do we have any other questions from people?
Yeah, could you expand a bit on the assumptions? So basically the second point on the takeaways. What kind of assumptions do you think might be least realistic in Marl or in cooperative AI?
Well, I'm mostly familiar with the game theory side of studies, Marl and cooperative AI. And I think out of those, the classical ones are the first example that I gave, right? Like the assumption that common knowledge takes no time to propagate, whereas in fact, in practice, they both have the social network propagation time, and also the speed limit by time, by light speed, right? Light speed comes, it's not that sci-fi when you think in terms of financial markets, right? Yeah, because those hundreds of milliseconds does matter a lot.
What are like the future experiments that you can run in regards to this work?
Maybe you want to repeat the question.
Okay, yeah. So the question is that what kind of future experiments would I expect to run in regarding to those, how to say, weakened or modified assumptions, right? Yeah. So I think one thing that would be interesting to see is that can AI, can basically. Like a lot of the previous Marl or cooperative AI experiments are conducted in a very closed loop or like closed system, and that's why it's fine to make the assumption of like instant common knowledge implementation, right? Because it's just a code running on your own computer, so like there's no time, light speed limit. There's no social network propagation. So I think just coming with scale, you naturally see like the assumptions kind of break up, or if somebody deploys those systems in the real world, you see those assumptions break up. And yeah, I mean, we can some interesting experiments definitely include, say, if we turn those traditional game theory settings into say, instead of this agent deploying some commitment or saying something to the other agent, what if we just give them, the API to call, Twitter API to make a tweet, and the other agent sometimes, occasionally checks Twitter, right? Or like checks the email, and then in this way you can like mimic the speed limit. Yeah, some nice theoretical way to study this. Maybe, of course, you can like assume some bounding rationality, but in my mind, those models are like both, they are hairy and they're hard to reason about, and then it's yeah, might as well do the experiments. Yeah.
Any something coming up online? Oh, someone's writing. Yeah, so your point there would be that that we want the naturalistic experiments in Marl and so on, just like making them more simulating this info propagation better.
Yeah. So the question is like, in future, those experiments naturally emerge because we give them those social network capabilities. Correct. Yeah. I think so, and I foresee that to happen. Right. Like you can make real money by manipulating social network sentiments. I mean, there exists this is just stock market. Like, right. I mean, people run pump and dump schemes because you can make bots that, hype some stock or concept up, as in like, people correlate their opinions with other people's opinions, and then, they join in and then buy the asset, and then pump and dump schemes are like very widespread. Yeah, and I think probably people have already done that. And there's also this other idea, like you can build a bot that analyze, let's say, the public materials of some company, and then analyze, that is this company potentially involved in fraud or not, and then your bot can like, generate some fraud report, and then like publicize it in the social network in order to, how to say, make the other person's stock price dump, right? And then you can profit off that. But okay, so there's a question saying like, how are the commitment devices being implemented with the AI agents? I presume this question ties into, how can we make the AI agent how can the AI agents make the commitments, right? Or where does the commitment live? So in that case, I think, realistically, it's probably going to be like the AI agent generates some, writes some code, deploys a website, and then like the AI agent uses email or social media to tell the other person, to tell, how to say, the world or like, other person, basically do a public broadcast of the website, right? And then the website kind of describes the rules of like, if you want to participate in my in this market, on this website, then you must do such and such. You can, like, for example, you can log in via your social media to like retweet something about my website, and therefore I give you some kind of I don't know, kickback. All kinds of growth hacking things are relevant over there.
So you answered that question of how does commitment devices look in agent AI?
Yes.
Your point there is that you can gain a lot of website interaction. You can game a lot of that. I guess the question also involves how do commitment devices work between agents so we avoid this scenario. What are some ways you imagine this?
Between agents, you mean like can they? Oh, okay. So the question is like how does commitment devices between agents work? And I presume the question is more about how do we make them credible, especially in a sense that agents cannot trust each other.
Yeah, and both human and AI.
Okay, yeah, and both human and AI agents. So I think, usually, when one person develops a website and then deploys it, then you can't see the backend code, right? Like, then you know, if it's just a random website, there's no way to check it, and it's easy to get scammed. Yeah, I don't know about you guys, but me sometimes, you know, I want to, especially being a non-US person, I want to apply for some visa, and so, you know, to apply for visa, you have to do a lot of paperwork, and the paperwork I often want to offload to somebody else to do that. So I go on and find some service, and there exists many websites doing such as services, but you know, those websites often look extremely sketchy, and then like in order to process the paperwork, they indeed need my passport information. Like I have to give them that. That's highly sensitive information, and like the website is indeed sketchy. I have been personally scammed, not scammed. Well, I mean, yeah, kind of scammed, like $500 or something on those kind of services, which is bad, but it's fine. And I keeps trying, you know, like there are a few services I like, but that is a real problem that we see. I don't think there are very good ways to resolve this. I mean, like one way would be, you know, sort of say you use, I mean, there exists some technology such as trusted hardware, right? Trusted execution environments in which you can make a hardware, and the hardware contains a cryptography, contains a private key, and then, you know, nobody sees the private key, and then it can encrypt messages and then process them, and then once, yeah, and then you can use services to attest to say that, oh, this hardware is indeed secure, and then you can host your website inside such a trusted hardware, and yeah, that's one way. There exists many other more futuristic ways, such as, you know, you can say host your market on smart contracts, right? Yeah.
Any other questions?
I see there's somebody typing as well. If
maybe one question: do you have thoughts on like how like in certain environments, like you have some agents that are like trying to extract maximum value, but like then you have like others who are just like doing a random thing. Like in financial markets, I guess like you have a mix of people optimizing and mix of people trading based on sentiment.
yeah.
And like how can we have like any takeaways on like for like risks in these environments, like when like not everyone is trying to optimize, but like
I see. So the question is that in an environment with mixed incentives, not everybody is like assumed to be perfectly rational. Then how do we mitigate the risks in those interactions? Yeah, I think that's a great question, and that ties into, you know, my you know, the takeaway points here, right? Like what kind of realistic assumptions can we make? Yeah, over there, I think you probably just have to, you know, build it out and then and then experiment with it more, right? Because what I just described, manipulating sentiments on social media, is essentially that, right? There's a large population with different incentives. How to say, fit the curve to, you know, placate to different audiences? Of course, over there, like the game is highly dynamic, right? So some people like there's the bell curve meme, right? Like there's left curve, mid curve, right curve, right? And then like, you know, often we see is that people deploy mechanisms that placate or appeal to different part of the curve, right? You may intentionally want to act downward than you actually are in order to attract the how to say, the left curves, which usually has less information than others in the market, and therefore, you know, their usage on your market is more valuable, right? Okay, so here's another question saying like, can we use SMPC in a setting such as an auction market to mitigate collusion? Can you elaborate on what SMPC is?
And also, you're welcome also to just unmute your mic. That's fine as well.
Oh, secure multi-party computation. I see. Yes, exactly. Yeah, sorry, I forgot about. Yeah, multi-party computation and fully homomorphic encryption can both achieve, like, you know, this credible commitment schemes. Yeah, as well as CP snarks. I forgot that as well. Okay. Can we use Yeah, I think secure multi-party computation can definitely run, run an auction market. The major concern would just be latency, right? It's uh they're not very performant for highly complex auctions. I think in a lot of those like social media situations, the auction or like mechanism that you deploy would probably be very complex. Yeah, but it really depends on the use case, right? Like if you expect the social media propagation speed to be slow, then I think it's fine to use secure multi-party computation because the common knowledge implementation speed is slow anyways, and as long as your mechanism runs like faster than that, it's fine. So yeah, it's just not ideal for low latency applications. Yeah. Which I think, in an AI agent world, AIs act way faster than humans. So maybe a low latency solution, such as a trusted hardware, is something that's more promising than cryptographic approaches.